Dear students, welcome and thank you for tuning in to this video with me, Dr. Al-Zube. We are still doing the videos of the kinematics of particle lecture from the Statics and Dynamics course. And in the previous previous videos, actually, we talked about an introduction about kinematics of a particle. We talked about the position and displacement, and then also we talked about velocity and speed. In this video, we're going to focus on acceleration because this is the third quantity that we want to make sure that we know how to identify for a particle that is traveling along a straight path. So acceleration in definition is the rate of change in the velocity of a particle. It's a vector quantity, which means that it could have positive or negative values. And we're going to talk about what does that mean. So when we talked about velocities and speeds, position and displacement, we talked about position, positive and negative as a reference to a point. In acceleration, the positive and negative means if I'm accelerating or decelerating. So, and typically the units of the acceleration are meters per second square or feet per second square, depending on the unit system we are using. So the instantaneous acceleration actually is the time derivative of the velocity. And we are going to focus a lot on that because that's very important in our examples. So in a vector form, A equals dv over dt, if you have your velocity as a vector form, in a vector form. If it's in a scalar form, A equals dv over dt, or that's the first derivative of the velocity, or it's the second derivative of the position s. And acceleration can, as I mentioned before, can be positive, which means the speed is increasing, or negative, which means the speed is decreasing. And that's a distinction between position and velocities in one hand and acceleration in the other hand. Accelerations, as you can read in the text, the derivative equation for a velocity and acceleration can be manipulated to get another formula that is very important for us, in which you can find the velocity as a function of position. And that is A as acceleration multiplied with ds. The derivative of the position equals v multiplied with dv. And we're going to use this in a couple of ways in the following videos. So this is acceleration and how we are going to be looking at it. Keep in mind, instantaneous acceleration, its derivatives, and we can do integrations and to go from acceleration to velocity to position, and also we can use the formula that can allow us to find velocity as a function of position, which is A ds equals v dv. Now, a quick summary of the kinematics relations of the rectilinear motion. Differentiation is very important, and also integration. Starting with differentiation, we differentiate position to get velocities, and we differentiate velocity to get accelerations. And those are the formulas. So if you have the velocity is a derivative of position, acceleration is a derivative of velocity, and also we have something A equals v dv ds. So you can have the acceleration by multiplying the velocity with the derivative of the velocity with respect to position. So the first two were a derivative with respect to time, and then I have a derivative with respect to position. In integration, we can integrate acceleration to get velocity, and you can integrate velocity to get position. And so if we want to find the velocity, you integrate acceleration, and if you want to find the position, you integrate the velocity. Note in all of these, and we do the integration limits, they're very important, and we're going to solve problems to show how we can use them. If you have S0 or V0, those are the initial position and the initial velocities of the particle at time equals 0. That's important in our analysis. So this is a quick overview of the kinematic quantities we are interested in, and in the following videos we are going to look into how can we use these quantities in solving problems of a particle moving in a straight line. Thank you for watching. Until the next video. Bye.